5.5, this is a repeated solution. It's a solution that happens 2 or more times. Okay, so you already kind of expected that to happen, like if you get x equals 2 twice. All right, and we'll show you an example of that in a minute. The more important part is, what does this do with the graph? Like if you have a single root versus a double root. Yes, and that says double, believe it or not. D-O-U-B-L-E versus a triple root. Okay? If you have a single root, the graph, whatever it's doing, just kind of goes right through it as if nothing's happened. Okay? It goes right through it. What's up?
You forgot the L.
D-O-U-B-L-E. There you go. Feeling better? All right. A single root just goes straight through it. Okay? Like it didn't even slow down, ask questions, whatever. A double root actually comes down and hits it and then bounces back the other direction. A double root will bounce off of it. It will touch it in one spot and then go the other direction. A triple root will kind of come down, slow down, hit that spot, but then go back and then keep on going the other way. It's going to look like it's turning around and going the other direction, but then keep on going. It's kind of like you're driving along, you're lost, you don't know where you are, and you kind of go, oh, am I going to go down this? No, that's not where I want to go, and you straighten back up and keep on going. It's that sort of thing, okay? But that's really the biggest takeaway from the idea of a repeated solution is, what does it look graphically? What does it look like on the graph? Okay? Here we go. Anybody still writing? I still got 3 people writing, so I'll pause for a second. Quadruple, and actually from here on out, they alternate. A quadruple, anything that's an even number will bounce off, so that's the 4th, the 6th, the 8th, the 10th, the 12th. Anything that is an odd numbered will slide through it like that. It will act like it's stopping, but then keep on going. Okay? It's just going to be sharper and sharper and sharper. Like, if you had like 17 of them, it might actually look like this. It just slows down so slightly that it looks like it's going straight through it. You follow me? Probably what's going to look like. Are we going to look at one of those? No. All right? We'll leave that to calculus. Actually, I don't even think they look at that in calculus. That's just like ridiculous. All right, so here we go. Problem 1. Problem 1. We'll start off. We'll solve it by factoring. So, is there anything I can divide out? 2. Okay. Anything else? An x. I can pull out a 2x. Well, this only has 1 x to give, but you're right. It's good to at least think about that. So if I divide it to 2x, what's that divided by 2x? 1x squared. Or you can just write the x squared. You don't need the 1. What about that one divided by 2x? Good. Negative 6x. Plus 9. Good. Negative 6x plus 9. And I'll attempt at cleaning this up. Wow. I'm not sure that's any better. Whatever. Okay? From here, the 2x comes along for the ride just like last week. And it's a trinomial, so I'm going to go ahead and you have 3 terms, so I'm going to pull out your parentheses. And 2 things go to the left, 2 things multiply to the right. What can we put on the left that multiplies to x squared? X and x. What can we multiply to the right that goes up to 9? 3 and 3. Okay, we'll try those. What would the signs be? Both negative. Good. Negative 3, multiply to positive 9 and add up to negative 6. Cool. All right, so last but not least, set it all equal to 0. So I got 2x. I got x minus 3. And x minus 3. And just solve. If I divide by 2, what's 0 divided by 2? 0. Okay, if I add 3 to move that one over, what do you get? 3. If I add 3 to get this one over, you also get 3. So that one has a double root. Cool. Does that make sense? We'll graph a few of them. It's not going to be as intense as you think. But like this one would have 1 root at 0 and 1 root at 3. And it would probably come down, bounce off, and then go through it like that. That's supposed to be an arrow in the other direction. That's roughly what it would look like. Cool? And we'll talk about that a little bit. All right, letter B. I think you can do letter B on your own. I totally think you can. We'll see. All right. But anyways, give letter B a shot. I'll pause it. Come on. There it goes. And that's what you should get. That was gorgeous. Thank you. And I'm pretty sure the microphone picked that up too. I'll play it for your mama. All right, here we go. So there you go. We got a 0 and 2 4s. All right, hopefully you divided it 5x and you went from there. Cool. All right, now I will say this. Do you have to write this line out right here?
No.
No. Okay, because hopefully you've already realized that this minus 4 is just going to become a positive 4. That minus 4 is going to be a positive 4. If it was a positive, it would become a negative. All right? And if you've already thought about the idea, it was like, well, if it's an x out front, is it always going to equal 0? The answer is yes. If you have an x just multiplied out front, it's always going to equal 0. Okay? So you can just look at that and say, well, that's x, 4, 0, 4, and 4. You can look at this one and say, well, that's 0, positive 3, positive 3. Cool? So no, you don't have to write out this line right here if you don't want to. But if you need to, do it. I'm dead serious. You're better off showing more work than you need just to get it right. All right, letter C. Letter C. Before we start factoring this sucker, what might you want to do first? Move the 14 over. Good. So the 14x cubed becomes what? Negative 14x cubed. Good.
2x minus 14x cubed plus 24.
Good. Equals 0. And that's a plus sign, not an and sign. All right. So can we divide anything out? A 2 and a x. So do so. If I divide the first one by 2x, I'm left with an x to the 4th. Good. But the next one would be what? It would be an x squared, okay. But what about the negative 14 divided by 2 would be negative 7. There you go. 24x divided by 2 would be a plus 12. Cool? All right. This is where certain people see the x to the 4th and they poop themselves. Please don't. It's actually a lot easier than it looks. All right. Where the x cubed, I divided it by an x, so the 3 went down to a 2. Right. There was no x squared. There was no x to the 4th. All right. So here we go. It's actually a trinomial. There are 3 pieces. So let's go like this. What are 2 things that multiply to x to the 4th? Good. X squared and x squared. What are 2 things that multiply to 12? Negative 3 times negative 4 is positive 12. Do they add up to negative 7? Yes. All right. And just to kind of be, you don't need to show this, but just to kind of be a little bit over, remember it's outside, inside. X times x squared times negative 4, that's negative 4x squared. Negative 3 times x squared, that's negative 3x squared. And those add up to negative 7x squared, which is your middle term. Okay? So don't let the x squareds and the x to the 4th creep you out. All right? All right, let me erase that. There we go. All right, so we have an x squared minus something. Okay? So let's go again. I'm going to do this one first. I'm going to do the x minus 4 first. Can anybody just, off the top of their head, factor the one on the right? It's a pattern that, yeah. And x minus 2 and x, not minus, plus 2. Good. They're different because it's got to get back up to that 0 in the middle. All right? So like I said, that's a pattern you've seen multiple times. All right, so we just took the square root of the 4, right, to get the 2? We took the square root of 4 to get 2, right? So this one, what's the square root of 3? The square root of 3. So we'll just go x minus root 3, x plus root 3. You can't evenly take the square root of it, so just leave it as a root 3. That's okay. Everybody still with me? That's really the hard part about this problem, is going from this step to that one. And that's okay. So here we go, real fast. This first one, if I set it equal to 0, what are you going to get? 0. If I set the second one equal to 0, you're going to get positive square root of 3. If I set the third one equal to 0, you're going to get negative root 3. If I set the next one equal to 0, you're going to get 2. What about the last one? Negative 2. Since I have the positive and negative versions of those, I can say x equals 0 plus or minus 2, because that's the positive and the negative, and plus or minus root 3. All right, now, if you want to, you can just say x equals that one, comma, that one, comma, that one, comma, that one, comma, that one. You can do it that way if you want. That's fine. Okay? But you're going to see this in textbooks and other things like that. All right? So, but you need to be able to recognize that this is the same as that, even if this is the answer you write down. You follow me? You have to be able to recognize both of them. Any questions on this? Do you think you could do the next one? I think you can. You give it a shot. We'll start here. First thing you gotta do is what? Move the 40. I'll get you started. So that's 4x squared, x to the fourth, I'm sorry, minus 40 x squared plus 36 equals what? 0. All right, so what can you divide this by? Can you divide it by a variable? Does this have an x to give? So it's just the 4. Go from there. Can't divide by an x? Divide by an x? Yes, all right, let's do this real quick.
You take the x when you divide 4x divided by 4.
No, that first one divided by 4, yeah, it would just be an x to the fourth. Does that make sense? Because you're just dividing the coefficients. You're not dividing the x's at all. X to the fourth, yep. Yep. And x to the what power? Good. Go from there. Ooh, that's not 2. That should be a 1. So it's 4. Yep. One math magician. Sometimes I think you'll think I'm a math magician. Oh, and I recorded all the way through that. Oh well. Let's see. Yeah, I just put it, you probably had a minus 1 and minus 1. They're the same things. Maybe that's true. Yeah. Multiplying in a different order is the same thing. One thing Algebra 2 at this point in time is going to start testing is your stamina. Is your ability to get all the way through the problem. You follow me? All right, that's one thing the rest of the course is going to stretch. Just be perfectly honest. All right, so if you've been getting by without practicing or doing your homework so far, that's probably not going to last for much longer. All right, so here's the issue I have with that. So, was this first step hard, dividing by 4?
No.
No, was breaking that into 2 pieces really that hard?
No.
No, once you saw the pattern, was breaking that into 4 pieces all that difficult? Not really. You probably weren't used to seeing that much, but the actual process of breaking that one and breaking that one is really not that bad. And then from there, getting your answers, all 4 of them, is really not that bad. The hard part is starting here and not petering out somewhere in the middle of it. You follow me? That's going to be the hard part for most students.
I don't understand the
The 4 one?
yeah.
All right, so here's the deal. Basically what I'm doing is when I'm doing the x minus 9, I'm ignoring all of that. And I just say x squared minus 9 breaks down into x minus 3 and x plus 3. Does that make sense? And then when I do the other one, I'm ignoring all of this and breaking that piece down. So I'm focusing in on just the piece I need to look at for the moment. All right? That's another thing this class tests, is being able to, in the middle of all the chaos, focus on the piece you need and deal with it appropriately. All right?
So you make just positive and negative the last one.
So
Like 9 and 1.
yeah, negative 3 times positive 3 is negative 9, and they add up to the 0 in the middle. Negative 1, positive 1 is negative 1, and they add up to the 0 in the middle. Cool? All right, let's turn the page. We need to get through the second page today. All right, we'll save the third page for tomorrow. So the next page, everybody needs a calculator. If you do not have a calculator, come grab one. All right? Oh, no, I apologize. You don't need it yet. This is easy. All right, so this says use end behavior to sketch the graph of the function. All right, end behavior. Remember, if it's a positive leading coefficient, does it go up and to the right, or does it go down and to the right? Up. It goes that direction. And if it's a negative leading coefficient, does it go up to the right or down to the right? Down. Okay? That's the only piece of information you remember from that unit. Or not unit, that little lesson, whatever. So here we go. Let's start off by factoring. Letter A. All right? Can I divide anything out of
1.
Well, I can divide a 1 out. Okay, about a letter. An x. I can divide it by an x. So divide that out. What are you left with?
X squared.
Good. Good. And then we'll break that down from there. I got a trinomial, so break out your parentheses. What are 2 things that multiply to the x squared? X and x. What are 2 things that multiply to negative 6? But add up to 1. 3 and 2. Which one is positive? Which one is negative?
The 3 is positive and the 2 is negative.
Good. Here's a way of thinking about that. You're adding up to a positive, right?
Yeah.
So you need more positives than negatives. So from here, your answers are x equals what? You got 0, negative 3, and
Positive 3 and negative 2.
positive 2. Remember when you set them equal to 0, so like x plus 3 equals 0, I got to subtract the 3 to get it over. All right, so you got to remember to flip those suckers. All right, everybody cool with that?
Yep.
That's nothing new. All right, the graph. The graph. We have 3 roots. We have 1 right here at negative 3. We have 1 right here at 0. And we have 1 right here at positive 2. The leading coefficient, is it positive or is it negative? Go back to the original question. Was the first number positive or negative? Positive. So we're going to start up and to the right. We're going to go down through the bar, go back up, curve back around, and come down like that. That's what they want us to do. Cool? Now, understand, the scale of that is not correct. The roots are correct, and the direction it goes in the end is correct. All right? But this might be really steep. This might be really shallow. You don't know. It might be something that looks kind of like this. Really shallow like that. All right, but that's what we're going for. Cool? All right, I want to do one more on this page, then we're going to go to the next page. All right, letter D. I think y'all can do B and C on your own pretty quickly, but letter D has something I want to talk about. Okay? First things first. Can you divide anything out?
No.
Does the 81 have an X?
I mean, the first 2, but the last 2.
Can you divide out a number? No, the first one, that one has a 1, and that one has no X's. So there's nothing to divide out. So here we go. 0 equals, break out your parentheses. What are two things that multiply to x to the fourth?
X squared.
X squared.
Good. What are two things that multiply to 81?
9.
9 times 9. Okay, can you rig those to get to a negative 18?
Yes.
Okay, what are they?
9.
Negative 9 and negative 9. Cool. All right. We still got x squared minus. So let's take care of the first one. What does that break down to?
X plus minus 3?
Well, is it minus 3, plus 3, or both? Both. It's going to have a positive 3 and a negative 3. Is the second one going to be any different?
No.
No. So x plus 3 and x minus 3. Cool?
So it's going to be 0 plus a negative 3.
Yeah, so I got a negative 3, a positive 3, a negative 3, and a positive 3. I have two sets of plus or minus 3. Those are your roots. Here, let me slide it up for you. Is that better?
Yep.
I just keep seeing you going like this. Because I know he's got a fat head and everything. I mean,
Dang, that sucks.
It's okay. He's called me.
I have.
I remember.
It's all right. All right, so here we go. We have two roots. One at negative 3, one at positive 3. And those are double roots. They happen twice. Do you remember what happens up to the graph of a double root? Does it go through the point or does it bounce off of it? It bounces off of it. An even numbered root, so we're going to come down, we're going to touch that point and go back up, come back down, touch that point and go back up. Basically a W. Now, granted, the actual graph might be really shallow like that. But what we're going for at the moment is just general, what does this look like? All right, and it looks like a W. Heck, it might even be something weird like this. It might come almost straight down, curve over, and then only barely bounce up like that, and then go straight back up like that. I've seen ones that do that. They're strange. But you know what? It's what it is. Cool? V-dub. That was a horrible commercial. Anyways, any questions on this? All right, let's go to the next page. All right. This is going to show up a little bit more as we go on through the rest of the chapter. Okay? Factoring using synthetic division. Use synthetic division to find all the zeros. All right? So here's what we're going to do. We're going to use our calculator to find what we can, and then use synthetic division to prove it. Does that make sense? So if you don't have a calculator, find a calculator, and plug this into y equals. All right? So I'm going to switch over. I'm going to switch over. For those of you on the video, sorry you can't see this. But we're going to go to y equals, and we're going to plug in x to the third minus 8x squared plus 11x plus 20. All right? Plug that into y equals. And hit graph. And you get something that looks kind of like that. Cool? All right, now I can't always tell much from that. So go to the actual table. If I hit second graph, it goes to the table. Where on this table does y equal 0? -1. Where else?
4 and 5.
4 and 5. Great! They all show up. All right, we're looking where y equals 0 because that means it's a root. That's where it crosses the x-axis. So 0, 0, and 0. So here we go. Let me switch back over. We are going to use synthetic division and divide those guys out. And I have to go back over here, hit settings, second page, go to that, and now I can reapply this. Okay, so I know, based upon the table, that -1, we said 4 and 5 are all roots. So we're basically going to divide each one of those out. So here we go. Which one you want to do first? I don't care which one. Any takers? Negative 1, sounds great. So let's do the negative 1, and then grab your coefficients. The first one is a 1. What's the next one?
4.
1, then what's next? Negative 8, then what? 11, then 20. All right? So let's run through the paces. Drop the 1. 1 times negative 1 is negative 1. Add them up, you get negative 9. Negative 9 times negative 1 is positive 9. Add them up, you get 20. 20 times negative 1 is negative. Add them up, you get 0. Okay, so what you have done, you have proven that negative 1, 0 is a point. That yes, negative 1 is a root. That's what you've done right there. All right? You can think of it like, it's not technically a proof, but you have shown that it's true. All right? Pick another one. Which one do you want to do? 4 or 5? 4. Okay. I heard more 4s than 5s. We're going to go with it. So drop the 1. 1 times 4 is 4. Minus 9 is negative
5.
Times 4 is
Negative 20.
negative 20. Add them up, you get
0.
0. Cool. You've proven that that one's true. All right. Now, at this point, you have a choice. You can either throw in the 5 and do it again, or you can say, hey, remember, like, this is your constant. That's your x. There was another one that would be your x squared. So you can say x minus 5 equals 0. So x equals positive 5. You could do it that way as well. So you got positive 5, positive 4, and negative 1 as your roots. Negative 1 as your roots. Cool. All right. Any questions about this? It's relatively straightforward. We use the calculator to find any roots that we can. But here's the problem. You're not always going to have even roots or whole numbered roots. All right? We're going to get some imaginaries. We're going to get some square roots. We're going to get some fractions. We're going to get all sorts of stuff. So I'm going to move down to letter D. We're going to move over to letter D, all right? I want you to put this in your calculator. Go to your calculator. Put that in your calculator. And then go to your table. Put it in exactly like you see it, and go to your table. Look to where y equals 0. Yeah, there's only one of them, right? Where's it at? It's at 1. I'll give it a few seconds for everyone else to see it. I think you're looking at the old one. Oh, you're looking at letter C. Or letter B. You're looking at letter B. We're doing letter D right now. But letter D, there is only one whole numbered root. And it is at 1. So we're going to start here. Divide it out. We got a 1. And then pull your coefficients. 3, negative 2, negative 37, 24, and 12. Cool? All right. Drop down that 3. What do you get? And what's 3 times 1? 3. Add them up. What do you get?
1.
Times 1 is?
1.
Add them up. You get?
36.
Negative 36. Times 1 is?
30.
Negative 36. Add them up. You get? That's on the video now.
12.
Negative 12. Times 1 is negative 12. Add them up. You get?
0.
0. So 1 is a root. Okay? From here, we can start factoring this. So if that's my constant, this 3 is an x to the what power? Third. So good. 3x to the third plus x minus 30, oh, x squared, I'm sorry, minus 36x minus 12 equals 0. And I am going to factor this by grouping. Because I have 4 terms, I'm going to try factoring by grouping. So, what is the biggest thing you can divide out of the first two? An x squared, and that's it. I know, right? Kumbaya. So, that leaves us with a 3x and a... What's this divided by x squared? 1. All right, to get another 3x plus 1, what can I divide the second 2 by? Negative 12. And you're right, indeed, we get a 3x plus 1. Okay. So, if that's what you get, do you remember? How do you find your two factors? What's one of them? Good. Good. All right. Now, I could factor this one, but let's just, since it's just an x squared, let's set these equal to 0. So I got 3x plus 1 equals 0. Subtract the 1, you get 3x equals... So x equals what in this case? Negative 1/3. All right, so there's one of them. I got x squared minus 12 equals 0. So move the 12 over, you get x squared equals 12. Where do we go from there? Square root it. So I get x equals... Close. What goes in front of it? Plus or minus. Good. So your answers are negative 1/3, plus or minus the square root of 12, and the 1 you divided out earlier. Those are your 3 answers. You ask, why is it plus or minus? Remember, every time you square root to get rid of a square, you have 2 versions, a positive and a negative. Anybody fried yet? No? Good. Let's do one more. Back up to letter C. I do want you to have a stroke. That's exactly what I want in life. Actually, no. I'm going to save letter C for tomorrow.